Saxon Algebra 1, Lesson 18. In this lesson, we study like terms and addition of like terms. First, consider like terms. Two or more terms are said to be like terms if they are both numerical terms or if they consist of the same letters in any order. If they contain letters, which represent variables, then they must also have the same number of each letter. Here are some examples. 5 and negative 37 are like terms because they are just numbers. Negative 3xy2xa and 8axxy are like terms because they consist of the same variables and the same number of each. We have one a, two x's, and one y. If we disregard the numerical coefficients of like terms, then the resulting terms will represent the same number regardless of the non-zero values assigned to the variables. For example, if we consider the terms negative 3xy2xa and 8axxy and throw out their numerical coefficients, we have for the first one, xyxa, we threw out the negative 3 and the 2. For the second one, axxy, we threw out the 8. So we just look at the letters themselves, the variables. Now if we substitute 2 for x, 3 for y, and 5 for a in the expressions on the right, we see that they have the same value. The first one is 2 times 3 times 2 times 5, and the second one is 5 times 2 times 2 times 3. The first one multiplies to 60, and so does the second one. They have the same values because of the commutative property of multiplication. It doesn't matter which order you write the numbers being multiplied, the result is going to be the same. So those are like terms because the variable part gives the same result when we substitute numbers. Addition of like terms. Suppose we apply the distributive property to the expression parentheses 3 plus 4 xy. Then we have parentheses 3 plus 4 xy is equal to 3xy plus 4xy, since the xy distributes within the parentheses. We can write this equality the other way around. After all, with an equals sign, what's on the left and what's on the right can be switched. So this gives us 3xy plus 4xy equals parentheses 3 plus 4xy. But 3 plus 4 is 7, and we do parentheses first. So 3 plus 4 in parentheses xy is the same as 7xy. Therefore, 3xy plus 4xy must be 7xy. Since 3xy and 4xy are like terms, we can add them, and their sum is 7xy. It's kind of like saying 3 apples plus 4 apples gives 7 apples. Let's look at another example. 4xmp minus 2pmx plus 6mxp. The three terms in this example are like terms since each consists of 1x, 1m, and 1p. Let's arrange the variables of each term in alphabetical order. Then we have 4mpx plus negative 2mpx plus 6mpx. This makes it apparent that we're dealing with like terms. We can apply the distributive property backwards. That expression is the same as 4 plus negative 2 plus 6 times mpx. But 4 plus negative 2 plus 6 is equal to 8, so the expression is equal to 8mpx. This shows we can add like terms by adding their numerical coefficients. Here's a very simple example. What is x plus x? We can answer this question by giving each term the numerical coefficient 1. So we have 1x plus 1x. You see, 1 times x is x. And then we can add the coefficients. In other words, we have parentheses 1 plus 1 times x. That's your distributive property backwards. And so it's equal to 2x. So x plus x is 2x. If we try to add non-like terms, we run into trouble. For example, we can't simplify x plus 2 because x and 2 are not like terms. In fact, x plus 2 is not 2x, because 2x means 2 times x, whereas x plus 2 is the sum of x and 2. Let's practice this. Simplify each expression by adding like terms. Number 1. 3x plus 5 minus xy plus 2yx minus 5x. Let's first write this as an addition problem. And let's put each term in alphabetical order, the variables. So that gives you 3x plus 5 plus negative xy plus 2xy, making them alphabetical there, plus negative 5x. Now we identify the like terms. We have 3x and negative 5x. Those are like terms because they contain only one x. And they add to negative 2x. 3 and negative 5 is negative 2. We also have negative xy and positive 2xy. Those are like terms. Negative xy and positive 2xy add to 1xy, or xy. It's the same as negative 1 plus 2 gives you 1. And finally, we have the lonesome 5, so we add that on. So that expression simplifies to negative 2x plus xy plus 5. Here's another one. 3xy plus 2xyz minus 10yx minus 5yzx. Notice that some of the terms have their variables in non-alphabetical order. So we will rewrite this as an addition problem and make sure that each term has variables in alphabetical order. That gives you 3xy plus 2xyz plus negative 10xy plus negative 5xyz. Now we identify like terms. The 3xy and the negative 10xy are like terms because each has one x and one y. 3 and negative 10 add to negative 7, so this is negative 7xy. Next we have the 2xyz and the negative 5xyz, and 2 and negative 5 add to negative 3. So these two terms add to negative 3xyz. And so we have negative 7xy plus negative 3xyz, which can be rewritten as negative 7xy minus 3xyz. Another example, 4 plus 7mxy plus 5 plus 3yxm minus 15. Again, we will put the variables of each term in alphabetical order, and we will write it as a sum. That gives us 4 plus 7mxy plus 5 plus 3mxy plus negative 15. The numerical terms, 4, 5, and negative 15 are like terms. They can be added. They add to negative 6. And then the other two terms, the 7mxy and the 3mxy, are like terms. They add to 10mxy. So there's our answer, negative 6 plus 10mxy. Fourth example, 3x minus x minus y plus 5 minus 2y minus 3x minus 10 minus 8y. We write it as a sum, and then we identify like terms. Let's see, we have x terms, we have y terms, and we have numerical terms. As far as the x terms are concerned, we have 3x plus negative 1x plus negative 3x. The 3x and the negative 3x cancel each other out, so we're going to be left with negative x. Then we have the y terms, negative y, negative 2y, and negative 8y. That's like negative 1y, negative 2y, and negative 8y. That's going to add to negative 11y. And finally, we have the numerical terms, 5 and negative 10. They add to negative 5. So we have negative x plus negative 11y plus negative 5, which can be rewritten as negative x minus 11y minus 5. A fifth problem. Negative 3 plus xmy minus y minus 5 plus 8ymx minus 3y minus 14. Again, we will write it as a sum, and we will place the variables of each term in alphabetical order. So this is what we have. Now we can add the numerical terms, negative 3 and negative 5 and negative 14. Let's see, negative 8 and negative 14, that adds to negative 22. We can add the mxy terms, 1mxy and 8mxy add to 9mxy. Then we can add the y terms, negative 1y and negative 3y add to negative 4y. And so we have negative 22 plus 9mxy plus negative 4y. And that can be rewritten as negative 22 plus 9mxy minus 4y. Well, that's all for this lesson. Your assignment is problem set 18 on pages 80 and 81 of your book.